the platform doing this, and if that box fails, you need another one to take over for it really, really quickly. That's where using Linux AHA and a bunch of other little tools allow you to accomplish that, so that in a matter of, well, if you design things really well, which doesn't take a lot of work, this can be done within a second. I mean, it's almost instantaneous. By the time the user realizes that the call is gone, the new server is actually already up and going, and when they try to place the call again, it'll go through because there's a server that's taken over for it. Another area, whoops, well, I guess we'll go ahead and go into this. Another area that becomes an issue when you build a network of multiple Asterisk servers is how do you figure out how to route calls among your servers? Because at any one time, there are different users registered to different servers, or different, if it's in an enterprise, you have different offices spread around the world, and they have different chunks of the extension numbering space belong to those offices. And so we have a protocol within Asterisk that's used to solve that problem, which is called Dundee, just a cute acronym that was made up by the person who invented it. One of these cases where you create the acronym and then you figure out what to expand it to so that the acronym will make sense. That's what got done here. But essentially what this is, and you don't have to understand all the technical details, is a way, again, to federate Asterisk servers together so that they all are aware of all the dialable routes that are within your network. And the important part of this is that it's not a centralized database that has to be maintained or that has to be replicated to all of the sites. It's literally a, if you think about, how many of you know about how Skype works? Very few. Okay, that's not a good example. It's literally a peer-to-peer model. So if you go, let's say you are an enterprise and you have 50 offices around the world that already have existing PBXs in them, and you're going to bring up a 51st office, and you've decided what chunk of your numbering plane is going to live at that office. Just bringing up that server and telling it that the other servers exist means that they now know how to dial the extensions of that office. You did not have to do anything to any of the other Asterisk servers. In a clustering environment, that's extremely important because it means nodes can come and go from the network without having to make any configuration changes anywhere. And as an example of the way that gets used, well, there's a couple of small graphs just so you have an idea here. I do apologize for the quality of the graphic here. This graphic has been copied between presentations, I think, about 4 or 5 too many times, so it's lost some resolution. But the idea here is you've got an enterprise, they've got Asterisk servers sitting at 4 locations, the state abbreviation's obviously there. And at the top left corner, you got someone who picked up a phone and dialed 1234, and the local server says, well, that's not here. All I know is that's not here. None of my local extensions are 1234. So it literally sends a query out into the network and says, hey, can anybody service this for me? And the one in New York, we happen to be in New York, oh, that worked out well, says, yes, that's here, and the call gets routed. The interesting thing about that is the administrator can move that extension to the Texas office, and a split second later, that's where the calls will start going. No one has to go to any of the other servers and change anything. Where that becomes really important is when the network gets bigger, and there isn't room on this chart, on this graphic, to label all of these elements. Just think of them all as Asterisk servers. Okay, these could be anywhere. They don't have to be. They could all be in one rack in a data center. They could be in multiple co-location facilities around the world. But the idea here, again, is you have one up there at the top left. Now someone has actually dialed the full 10-digit type E164 number, and that server says, I don't know how to route this call. What it's actually doing, I'm going to see how much time I have here. Yeah, there's plenty of time. What it's actually doing is sending a request to the 2 peers it knows about, because it only knows about 2 peers, the one up to the right of it and the one down to the left of it. And the one up to the right of it says, nope, I don't know where that is, and I don't have any more peers, so you'll have to look elsewhere. And the one down to the left of it says, no, I don't know where that is, but I have another peer, I'll ask him, her, whatever you want to use, and so on, all the way around the network until the one that finds it has gotten a route. Once that has happened, all that information is remembered in the network for a configurable period of time. So the next time someone somewhere in the network dials that same number, it goes to that extension, that goes to that server. If this server I don't have a laser pointer. If that server was to be taken out of service, not crash, but be taken out of service under normal circumstances, you would go to the console of that server, tell it that you wanted it to shut down, and the first thing that it would do is broadcast into the network that it can no longer service any of those routes. If some other server in the network could service them, but maybe it costs more, so you weren't choosing that one before, suddenly the network reconfigures itself and you're off and running. So this is something that people have used for a lot of really creative applications in that area. I guess I've pretty much already covered what all of these things do. Inside your own network, the fact that the model, the protocol between the servers is encrypted and uses trust is probably not that important. Where it becomes important is when you start interconnecting to carrier networks and lots of other interesting things. So, we'll make a quick summary here. I think I'm just about right on time. It is possible, for those of you who have not done it or even attempted it, to deploy Asterisk in small or even large clusters today in both enterprise and carrier environments. And obviously those environments are very different because the services that you're providing tend to be very different. The most common deployments, though, are not just Asterisk. They are Asterisk plus a bunch of other components. And the reason for that, again, is because the open source world tends to be everybody makes a tool, you plug all the tools together to achieve the solution that you want, like a big jigsaw puzzle, and when you get where you need to go, you have your kind of final solution. And for those of you who have not already used Asterisk, although that's a very small portion of this group, if you are interested in doing so, it's a very easy thing to add to an existing network via almost any means that you want. So if this is something that you're interested in playing around with, it is not something where you have to say, well, I have to take out this big chunk of my network and there's a big risk associated with that. It's very, very easy to add on there. So, all right, that's the end of my slides. Anybody have any questions? Yes?
Is there any best practice model for deploying where you have to talk about versions of these different products that may go out there today and we're going to